Hello. We're coming into another session today, which is what we'll be discussing, paper 2 of Pahang, year 2022 chemistry. All right. Firstly, let us understand a little bit format of paper 2. Basically, paper 2, once if you can actually master your essay, what people will always love to call it as essay, or what I would say is a stimulus form type of questions, normally you will be able to score. All right, now let us come down to the questions. Okay, let's look at the first question from section A. Okay, diagram 1 shows the heating curve on ice. So basically this is the heating curve on the ice itself. All right. Okay, A, state the type of particles in ice. So what are the type of particles? So when you are asked this type of question, type of particles, it will be either atom, molecule, or ion. All right, let me take my A. So in this case, because if it is in ice formed, all right, is in ice form, normally it's not atom because ice comes from water. So ice is basically, this is molecule. Okay, you always look back to its original state, which is water. Okay, now what is the meaning of melting point? So in this case, our melting point is at BC. This is what you call the melting point. Okay, the melting point is when the state, okay, of a matter changes to another form of state of matter. Okay, so in this case, what does it mean? Melting point is the temperature, okay, when a state changes its form to another state. Okay, so this is what we call a melting point. So when you are asked melting point, for example, in this case, okay, you don't answer it just as BC, but in fact you have to insert as 0 degrees Celsius. But only the thing is, it's not stated here what is the meaning of melting point in diagram 1. Okay, if it's in diagram 1, again you have to mention the meaning of the melting point in diagram 1 is when the ice changes from solid state to liquid state, okay, at 0 degrees Celsius. Okay, so be careful with what is given in the question. All right, now let's look at C. State the physical state of ice during the melting process. If it's during the melting process, basically it is what you call as meaning it's melting lah. All right, so it's the temperature whereby it's at melting point. Okay, so the state is normally solid and liquid at the same time. Okay, that's what we call the physical state, right? Now, why does the temperature remain constant between B and C even as heating continues? So basically, it remains the same, okay, because of the fact that it's converting, all right, it's changing into another state at that particular time, all right? Okay, so how do you put this answer? Okay, number 1, you need the heat energy is absorbed. Okay, point 1 is the heat energy is absorbed. Right? As for point 2, okay, for point 2, what we will be looking is to overcome the force of attraction between the particles. So it's actually quite easy, but I don't advise you to use P1 or P2. So during exam, you can just put 1 or 2. All right, because what is more important is the points that is needed, okay, or required for you to secure your mark. All right, so that's for this naphthalene question. They can even give you a state whereby they replace naphthalene as acetamide. Okay, so you have to look at this type of question as a bonus question, whereby how much marks they give you, you make sure you score and secure that mark full. All right, now let's look at question 2 now. Okay, table 1 shows some physical properties of group 17 elements in the periodic table of elements. Okay, so we've got this. State the other name for group 17 elements. So you've got chlorine, bromine, iodine. These are all what we call the halogen. You must know this name lah, actually. Okay, it's like for group 18, we will call it as inert gases. All right. Now, B, state the change in atomic radius when going down group 17 from chlorine, bromine to iodine. Explain your answer. So now if we are basically going down the group, you can imagine the atomic size definitely will be bigger. All right. But how do you explain? First thing, of course, you need to, first point, it has to be the atomic size, atomic radius increases. Okay, this is a very important point. Okay, very, very important point. You need to explain that the atomic radius will increase. Then only you stress more on the size itself. Okay, just explaining the size alone is not enough. All right, so when the atomic radius increases, in a way the number of shells filled with electron increases. Okay, so the number of shells filled with electrons increases. So this is the second mark or second point which we look for. Okay, so that's for question 2. Now let's look at 2C. Draw the arrangement of particles for bromine at room temperature. Now you should be already know, okay, that means you should be able to tell me already halogens at room temperature is normally at what state. Okay, halogens at room temperature are basically a liquid form, but they can undergo sublimation. All right, sublimation to turn into the gaseous form. So bromine is actually in liquid form. Oh, I can hear thunder and lightning outside actually at the moment while I'm recording this. Okay, so this, you just roughly draw a few sets of arrangement of particles to show that this is actually liquid form. Okay, now D, state one safety step that should be practiced when handling chlorine and bromine in the laboratory. So normally when we are handling this kind of poisonous chemicals, we will normally perform the experiment in a fume chamber. Okay, so it is handled in the fume chamber. Okay, so just remember, anything that undergoes sublimation normally, that means its initial form turning into a gaseous form, normally it will be done in a fume chamber, especially when it's something to do with poisonous gases. Okay, so that's for question 2. Now let's look at question 3. Diagram 3 shows green plant undergoes photosynthesis to produce compound X with the molecular formula of C6H12O6 and oxygen gas. What is the meaning of molecular formula? Okay, a molecular formula, actually this one is a definition which you should know. All right, so a molecular formula is a chemical formula. Okay, is a chemical formula that shows the actual number of atoms okay, the actual number of atoms of each element in a compound, okay, of each element in a compound. So you must be careful because basically when it comes to definition question, it must be a really complete, okay, definition, otherwise marks will not be awarded lah. All right, now next let's look at this. Name compound X. So if we have compound X, okay, photosynthesis to produce compound X with molecular formula of C6H12O6, this is basically glucose, okay, glucose. Normally it's glucose, sugar. That's what the use of photosynthesis, and this is the food for the plants. All right. Okay. C1. Describe the qualitative and quantitative information that can be obtained from the chemical equation in diagram 3. The moment you are given this type of question, do not hesitate actually to just straight away write that normal statement, which we will always write, that is 6 moles of water reacts. Plus means reacts, arrow means produces. Okay, so 6 moles of water, or if you don't feel comfortable writing in full, you can say 6 moles of H2O reacts with 6 moles of CO2, CO2 to produce, to produce how many moles? There will be 1 mole of C6H12O6 and 6 moles of O2. Okay, so where does the 2 marks come from? Basically 6 moles, 6 moles, 6 moles, 1 mole, there will be 0.1. 0.2 if when you are able to mention react and produce every single item as stated, then only you deserve your 0.2. Okay, so that's how you secure your marks. Now, let's look at C2. Calculate the volume of carbon dioxide required to produce 1 mole of compound X. So you know that in this case, 1 mole of compound X, okay, will react with 6 moles of O2. Oh, you need how much of carbon dioxide? Okay, so now you need 6 moles of CO2 to produce 1 mole of C6H12O6. So 6 moles of CO2 produces 1 mole of C6H12O6. So now you are required to calculate the volume of carbon dioxide gas required. So if 1 mole produces 24 dm cube, and in this case you've got 6 moles of CO2, so volume of CO2 needed is equal to 6 times 24, which is 144 dm cube. Right? 144 dm cube. So where does the mark come from? This one will be your 0.2. Right? 0.1 will be this one, this statement. Okay, you are able to mention how do you go about the 1 mole which actually produces 6 moles of CO2. Okay, so that's for question 3. All right. Okay, so for this first particular question, it will be preservatives. All right. Now let's look at the second one. Okay, 2. Why the types of food additives in 4A1 is added to the pickled chilies? Give a reason. So this type of food additives are normally commonly found and easier to be used. All right. So normally we use it to ensure, okay, the pickled chili lasts longer. Okay, the pickled chili lasts longer. So basically the reason is to ensure the pickled chilies last longer. So that's just 1 mark lah. Okay, there's no necessity for you to add too much because of the fact that it is a 1 mark question. Okay, diagram. Let's look at the next question. Okay, B. Diagram 4.2 shows the structural formula of salt and iron. Salt can be prepared from natural sources through the process of hydrolysis of oil or fat by alkalis. Okay, so this is the structural formula of a soap and ion. Okay, which is the negative ions. Now, name the process to produce soap. So basically, if it is a process, then this is what we call the saponification process. Very straightforward, okay? Now, based on figure 4.2, identify the part that dissolves in water. So you have to identify which part dissolves in water. You have part A and part B here. So part B will be the one that actually dissolves in water, okay? Okay, part B, yeah. And part A will be the one that actually dissolves in fats or the grease. All right. Let's look at C. Mazia uses brand Y whitening cream bought online. After a week, Mazia's skin is brighter but irritated and peeled. Mazia took action to check the ingredient content of the whitening cream in the National Pharmaceutical Regulatory Agency website. She found that the whitening cream had been withdrawn from the market because it contained harmful chemical Z. 1. Suggest the name of harmful chemical Z. So normally if result in bleaching, okay, especially in pharmaceutical products, okay, is usually mercury, usage of mercury. That's why her skin looks much brighter after just 1 week of usage, okay. And mercury is quite common in whitening products, which actually usage of it, just a little bit of usage of it can actually cause the skin to brighten within a very, very short period of time. All right. 2. Explain the effects Mazia will experience if she continues to use whitening cream containing harmful chemical Z in a long period of time. So 1, it will definitely damage the kidney. All right. Mercury is a very poisonous substance, okay? So first, he will attack your kidney, okay? It will damage the kidney or nervous system. That's 4.1. And in order to secure your second point, how you need to explain a little further, all right, by if it is absorbed into the bloodstream. Okay, so these are the 2 points which is needed for this particular question. All right. Anyways, this question is quite a generalized point, so it doesn't limit down to just the kidney alone. You can also try to put in series of things which mercury actually affects. How does mercury actually affects our body system? All right. Okay, that's for question 4. Now let's look at question 5. Diagram 5 shows the Great Pyramid of Giza, which is made up from ceramics. Okay, according to the analysis of historians, this pyramid was built between 2560 and 2580 before century. Okay, so this is the pyramid. 1. State the meaning of ceramic. So you can't run from definition. You definitely need to memorize lah. Okay, so a ceramic is a solid made up of inorganic and non-metallic substances. Okay, a solid made up of inorganic and non-metallic substance. That's what we call a ceramic. All right. Now, 2. State one's characteristic of ceramics that allowed the Great Pyramid of Giza sturdy until now. So that particular character is, okay, so that particular character will be, makes it sturdy. Okay, it's because of the fact it is hard and strong. All right, let's look at question B. Table 5 shows 5 types of composite materials, V, W, and X, and their components. Okay, so V, the composite material V, contains components like glass, copper 1 chloride, and silver chloride. Okay, whereas for W, it contains yttrium 3 carbonate, barium carbonate, copper 2 carbonate, and oxygen, and X contains concrete and steel. Okay, based on table 5, identify the composite material V, W, and X. So for V, it's a glass. It contains copper 1 chloride and silver chloride. So this is a photochromic glass. Okay, let's look at W. This is a superconductor because it contains yttrium 3 carbonate. And finally, concrete and steel. This is what we call the reinforced concrete. For X, sorry. Concrete. Okay. Now, 2. Composite material W is used to make supermagnet. State the 2 characteristics that make composite material W suitable to make electromagnet. Based on the characteristics, give an example of the use of composite material W in medicine. So what would that be? The fact that it is light, number 1. It has strong magnetic force, and also it has a magnetic resonance imaging machine. Okay, so this composite material, because it's a supermagnet, all right, so it will be light. That's for point 1. Okay, for point 2, it has strong magnetic force. And point 3, okay, point 3 is a magnetic resonance imaging machine. Okay, magnetic resonance imaging machine, MRI. Okay, the MRI machine, we always use MRI, but we always forget what is the entire full name of MRI, right? Okay, now, so now we are at question 6. Okay, diagram 6 shows series of reaction for propene. Okay, whereby you have propene going through hydrogenation. All right, going through hydrogenation, and then to produce compound P. So if it's propene undergoing hydrogenation, normally this is what we call a propane. Okay, and then 300 degrees Celsius, 60 atm, H3PO4. Later on we will get down to that. All right, to produce compound R. All right, this is hydration. Okay, this is hydration here then, because the addition of water. In other words, your propene is converted into propanol. So I would say when you meet with diagrams like that, normally what do you first thing do is you go through the diagram without reading the question first. Okay, that means you fill in whatever loopholes you needed there, okay, in order to make sure that you are sure of what you are answering first. Okay, so in this case we also have this substance S. Okay, and the production here is propyl ethanoate. So in other words, substance S will be ethanoic acid. All right, now let's look at the question. Now we look at the question. Based on diagram 6, A1, state the homologous series for propene. So the name is propene already, so the homologous series will be alkene. All right. Now, state the molecular formula for propene. So propene is something which contains 3 carbon atoms, and the general formula for alkene will be CnH2n. So in other words, for propene, the molecular formula will be C3H6. All right, let's look at the third one. Combustion of propene produces more soot than compound P. Calculate the percentage of carbon by mass for propene. So propene, you have 3 carbon atoms. So 3 times 12 divided by the RMM, the relative molecular mass for the entire propene, which is 3 times 12 plus 1 times 6. And then you want to get the percentage times 100%. This is a very important step because why? Some candidates, when they fail to write down this certain step, they just lose marks without reason, okay, which is quite pity lah, I mean, because you could have secured your full mark, but because of that, you could not get your mark, all right? So in this case, 85.71%. All right, that's how you get your first 1 mark. Okay, 4. Polypropene is a polymer of propene. Open burning of polypropene can pollute the environment. Explain. So polypropene is a polymer. Yeah, we agree with that it's a polymer. So how is it that it can actually pollute, okay, cause environmental problem? So firstly, it will release, okay, poisonous gas. Okay, so point 1, release of poisonous gas. And then what will happen when poisonous gas is released? It will be soluble in rainwater, and hence it will produce acid rain. Okay, so acid rain due to dissolving in rainwater. Okay, now let's look at B. Write the general formula for compound P. So what is compound P just now? If we look back, it is a propane, an alkane. So an alkane has a general formula of CN H2N plus 2. Okay, CnH2n plus 2. So that's the formula of an alkane. Okay, now draw two isomers of compound R. Compound R is a propanol. So what I would like to do normally, okay, propanol. Normally, if you are asked isomer, I will always shift the functional group first. Okay, so first we have this one. And this is what we call propan 1-ol. When it comes to naming, IUPAC nomenclature, okay, especially when they are asked about isomer, you have to put 1 in the middle. Okay, now, and then we're going to shift the OH, next OH under the second carbon. Okay, under the second carbon. And this is what we call propan 2O. So there you have it. Just simply like that, you can have two isomers already. Okay, so it's not that difficult actually. You just shift, your focus first is normally on functional group. If functional group you cannot, you are unable to shift, no matter how you shift, the name is still the same, then only you start disturbing the little methyl groups. Okay, normally is that is the method. All right, next, name the compound S to produce propyl ethanoate. So compound S will be compound S. Let's look at this. Propyl ethanoate. Because we've got propanol, propanol contributes to the name propyl. So in other words, the other one has to be ethanoate. And in order for esterification, propyl ethanoate is an ester. In order for esterification to occur, you need a carboxylic acid to react with alcohol. So in this case, the carboxylic acid here is ethanoic acid, which is why the compound S is ethanoic acid. So for carbon compound, if you were to ask me, I would say it's not a very difficult topic. But first, you need to grasp hold what is going on in this particular topic and closely relate and connect each of these homologous series into each other. Then only you can relate it and it becomes an easier topic for you. Okay, because most candidates, why they fail to answer these questions in carbon compound, the only thing is that they cannot relate and connect among all these homologous series. The moment you can break through the connection of all these homologous series, this topic should be quite easy for you. All right, now, okay, now let's look at question 7, which is on thermochemistry, okay, which is in the 3rd chapter of Form 5, thermochemistry. Table 7 shows the heat of combustion for fuel A and fuel B. Fuel A has a molecular formula of C8H18, which is what we call octane, all right? And then its heat combustion is negative 50.13, negative 5,013 kilojoule per mole. Whereas for fuel B, it has a molecular formula of C12H23 at negative 10,124 kilojoule over mole. So A, what is meant by heat of combustion? So heat of combustion is normally the heat which is released, okay, when 1 mole of substance completely burn in excess oxygen gas. It has to be excess oxygen gas, okay? So heat released when 1 mole of substance is burnt in excess of oxygen gas. Okay, now B, based on table 7, calculate the fuel value for fuel A and fuel B. All right, now for fuel A, you have to calculate the fuel value, meaning you are going back to Q, okay, Q, which is MC theta. All right, now how do we answer this question? As for this case, we take back the RMM. Okay, we will use back RMM. So the RMM for A will be, okay, A has a molecular formula of C8H18, so meaning 8 times 12 plus 1 times 18, which is the value at 114. Okay, the value at 114. Whereas for B, RMM of B, C12H23. So 12 times 12 plus 1 times 23, which is the RMM is at 167. Okay, so fuel value of A is equals, you have to take 5013, all right, divided by 114. 114, okay, and then you will get 43.97 kilojoule. 43.97, okay, gram over kilojoule. Okay, this one is, okay, let me guide you on how to cut the formula. Kilojoule, wait, I'll put this on a separate piece of paper. Okay, fuel A is, okay, just now what did we get? 5013 kilojoule over 1 mole. Okay, that's the unit, following the unit. Whereas for RMM, okay, the RMM unit is, okay, let me check for a while. I've forgotten suddenly. Kilojoule. Gram over mole, if I'm not mistaken. Is suddenly it slipped out my mind. It is because our mass, okay, wait, mole is equal to gram over RMM. So your RMM is equal to gram over mole. So this thing will be, okay, just now the one that you calculated, the RMM is 114, right? So 114 gram over mole. Actually he divide, not multiply, divide, sorry. Okay, he divide. So when you take this, okay, and multiply the other way around, it becomes 1 mole over 114 gram. This thing you cut off. So automatically your final answer will be 5013 divided by 114 kilojoule over gram. So your final answer will be 43.97 kilojoule over gram. So I hope you understand the fact that sometimes you do need to apply some of your little physics in, because in physics I believe you are playing along with the units as well. So this is what you should do also. Instead of memorizing, you go along playing with the units. Okay, so this is the answer for fuel A. Kilojoule over gram. Okay, kilojoule over gram. You need to write down the final unit, otherwise you will not get the answer. Okay, what about fuel value for B? Equals to how much are they? 10124 divided by 167. If along the way during your working you don't write down your unit, it's okay, because it will not do any harm. But your final answer, it has to be in the correct unit, otherwise they will not give you any marks. All right, so this one 60.62 kilojoule over gram. Okay, so that's the method. I think this is quite a challenging question, but if you can understand on how do you play along with the unit, it shouldn't be a problem for you. All right, quite tricky lah. All right, okay, now let's look at 2. Ahmad is a lorry driver. Choose fuel A or fuel B, which is more suitable to be used as fuel for his lorry. Justify your answer. So which one would you use? Justify meaning you have to choose one. All right, you will choose fuel B. Why is it that we're choosing fuel B? Because of the fact that the value, okay, the heat, the value of the heat is much higher compared to A. Okay, so the fuel value of B is higher than A. Just simple as that. Okay, we always choose which one that has a higher fuel value. Okay, because we can do like, it's called more of energy conserving. That means we save up a lot of energy. All right. Okay, 3. Calculate the heat released if 0.5 mole of fuel A burnt completely in excess oxygen. So now we have to take, okay, according here you have 0.5 mole of fuel A burnt completely. So you just take 5013, that's your value just now, times 0.5 only. Okay, which comes down to the final value, which is at 2506.5 0.5 kilojoule. Okay, now let's look at question 3. C. Diagram 7 shows the temperature readings for 2 sets of experiments to study the heat of neutralization of sulfuric acid and hydrochloric acid. Okay, we've got set 1 and set 2. The initial temperature for set 1 is 28.0 degrees Celsius, and the highest temperature it went up to 41.0 degrees Celsius. Whereas for set 2, initial temperature is at 28 degrees Celsius, and the highest temperature it went up to 54.0 degrees Celsius. Based on observations for set 1 and set 2 in diagram 7, 1. Compare the changes in temperature and explain your answer. So from here we can say that you've got sodium hydroxide reacting with sulfuric acid, whereas hydrochloric acid is sodium hydroxide. It has a higher value, okay, compared to when it is between sulfuric acid and sodium hydroxide. Now, how do we explain that? Okay, first, the temperature change. definitely have to go through the temperature change, because that's the one that we actually can see the most obvious. Okay, so the temperature change in set 1 is higher compared to set 2. That's 4.1. Is higher than set 2. Okay, then 4.2, we have to justify, we have to explain why do we choose it that way. Okay, because sulfuric acid is due to the fact that, oh, okay, there's a mistake here, errata actually. The temperature is the other way around. Okay, an errata here actually. Okay, so for sulfuric acid, it has the highest temperature it was 54, and for this one will be 41. Okay, so okay, next let's look at point 2. We have to justify what is the reason behind this. Okay, so first thing you can say is because of the acid, the type of acid that is used here. So sulfuric acid is a diprotic acid, whereas hydrochloric acid is a monoprotic acid. Okay, that's the first thing. And then you have to explain further, okay, to actually support the answer that you mentioned in point 2. Okay, how is it that the concentration of hydrogen ions in sulfuric acid is twice higher compared to hydrochloric acid? So the concentration of hydrogen ions in sulfuric acid is twice of hydrochloric acid. Okay, so these are the 3 points. So in besides being in thermochemistry alone, you definitely need to be well versed with your acids and bases when it comes to neutralization part. All right, now 3, predict a change in temperature if hydrochloric acid in set 2 is replaced by ethanoic acid of the same value and concentration. So what do you think? Now we change it to something which we call the weak acid. So if it is weak, definitely the dissociation of hydrogen ion will be much lower compared to the strong acids. So in other words, you can put in your answer as change of temperature becomes lower. Okay. Okay, becomes lower. Definitely it will go lower because of the fact that it's an weak acid. But you cannot say that it's half. Okay, it's half of the previous one, because why? It's not mentioned that, okay, the dissociation of weak acid in water is half. Okay, that means maybe it can be 3/4, it can be 1/4 only. So you cannot assume that it's half. It's not half. Okay, let's look at question 8. 8a, diagram 8.2 shows the apparatus set up to investigate electron transfer at a distance in redox reactions. Okay. So first, I will always advise students, when it comes to questions like this, identify your oxidizing agent first, which is in this case the bromine water. It's an oxidizing agent, meaning it undergoes reduction. All right, it undergoes reduction. So definitely this side will undergo oxidation. All right, now then only we look at the question. Based on diagram 8.1, 1. What is the function of sulfuric acid? Actually, sulfuric acid here serves like a salt bridge. Okay, in other words, is to complete the circuit, to make sure the circuit is completed, and or in other words, it allows movement of ions. Okay, to allow movement of ions. All right, now to write the half equation for electrode X and electrode Y. So let's look at X. X, we've got iron 2. So if it were to be iron 2, if it's undergoing oxidation, meaning it loses electron. So iron 2 will be iron 3 plus electron. Okay, now for electrode Y, bromide. Okay, the bromide ions are undergoing reduction. Reduction meaning it gains electron. Okay, so you see, when you have identified it as early as possible as the diagram, without looking at the question first, when you come to answering questions, it becomes very simple for you. Okay, now state the change in oxidation number for bromine water. So bromine water is very obvious, is 0, and then he become negative 1. So 0, 2, minus 1. All right, now let's look at B. Draw labeled setup of apparatus that could be used for an experiment to investigate the transfer of electrons at a distance using all the materials and apparatus in diagram 8.1 except the U-tube and the retort stand. You are also supplied with potassium iodide solution and acidified potassium manganate 7 solution to replace iron 2 sulfate solution and bromine water. Any other suitable apparatus can be used to modify this experiment. Show the direction of electron flow in the drawn diagram. So, firstly, you need to know what is going on. Okay, in other words, normally what is closely related to U-tube is normally the experiment which includes salt bridge. Okay, usually all right, usually the experiment which includes salt bridge lah. All right, so the diagram is roughly like this. Wait, okay, so this is roughly the diagram. Okay, so how is marks awarded? Okay, first you need to make sure this is a functional diagram. How do we check whether it's a functional diagram or otherwise? By making sure that there is this, they normally use filter paper here as the salt bridge. This is the salt bridge. It's serving its purpose as a salt bridge, and it's normally a filter paper. And then it must be carbon electrodes only, dip into suitable solutions, okay, and connected to a galvanometer. Then this is considered a complete circuit, or point 1, what do we call functional diagram. Okay, okay, for point 2, what we are looking for is label of substances, carbon electrode, okay, and also your sulfuric acid. Okay, we look for this sulfuric acid, carbon electrodes, and suitable aqueous solution. That is point 2. Suitable solution, carbon electrodes, and galvanometer. Okay, now what about point 3? Point 3, you need to show the electron flow, because there is one more instruction here. Sometimes we get to carry out drawing that we've forgotten there is one more part of the question, that is showing the direction flow of electron flow. That will be your point 3. So that is how you secure your 3 points for this type of diagram. All right. Okay, now let's look at question C. Anna. This question C is quite closely related to paper 3 in the year 2021 when the student first took their UAS practical exam. Okay, so let's look at this. It's quite closely related lah. Okay, it's quite close. Now, a piece of blue litmus paper is dipped into a concentrated sodium chloride solution, NaCl, and placed on a piece of glass slide. Two carbon electrodes R and S are placed on the litmus paper. The electrodes are connected to the battery as shown in diagram 8.2. Okay, now blue litmus paper soaked in concentrated sodium chloride solution. And this is electrode R and electrode S. Table 8 shows the observation on the blue litmus paper after 15 minutes. Electrode R, the blue litmus paper turns red and then bleached. S, the color of blue litmus paper remains unchanged. So these are all the E0 value. Okay. Based on table 8, explain the differences in the observation of the blue litmus paper at the electrode R and the electrode S after 15 minutes. All right. Now, so in R, it actually got bleached. But in S, the color of blue litmus paper remains unchanged. So how do we explain that? So firstly, hydrogen gas. Okay, hydrogen gas is produced at the electrode S, while chlorine gas is produced at electrode R. This is more like electrolysis lah, actually. Okay, you're doing electrolysis, just that instead of using beaker, we are just putting it in a deep litmus paper only. Okay, so that contains an NaCl. All right, so the charge is still follow positive and negative. Okay, that means positive in electrode R will attract chloride and also hydroxide ion, whereas for S it will attract H plus and also Na plus. But the fact of the E0 value, max H plus is more to be discharged instead of sodium ion. And then for the E0 value, chloride is the one that will be discharged compared to hydroxide because of the E0 value. You see, the one more positive, okay, it will be the one that actually discharge. Okay, it will be discharged at the anode. So how do you explain based on the differences in the one? So hydrogen gas, okay, will be produced in electrode S. Okay, whereas chlorine in electrode R. All right, just straight to the point. Don't have to beat around the bush telling so much stories. Okay, now hydrogen ion, why is it that? Because it discharges at electrode S because the E0 value for hydrogen ion is more positive than sodium ion. So in electrode S, okay, E0 value of hydrogen is more positive compared to Na plus. Yes, okay, compared to Na plus. Makes it easier to be discharged. Okay, in electrode R, E0 value of chloride ion, okay, is, okay, if you compare chloride ion with hydroxide, chloride ion is more positive also. Okay, chloride ion is actually it's not E naught value in this case. Wait, it's because of the concentration. Okay, because I forgot. Okay, it's mentioned here concentrated, not E naught value. This time it's because of the concentration that makes chloride ion is discharged instead of hydroxide ion. Okay, so not the E naught value, sorry, but the concentration of chloride ion is higher, which makes it easier to get discharged. All right. Okay, so that is a 3 marks question. So that's it for section A. Okay, we will come back to section B in a while. Okay, now let us continue with section B. All right, question 9. All right, question 9. When you see different pots, you should be able to predict actually what type of question is this. Okay, so we can see that there will likely be, it might likely be rate of reaction question, okay, which you should be happy because you get rate of reaction question. Now let's look at question 9a first. Diagram 9 shows two different types of pots. We've got pressure cooker and aluminium pot, okay, from diagram 9. Hidayu wants to cook bone soup for dinner. Based on figure 9, which pot of bone soup will cook faster? Explain. So if it's bone soup, definitely the one with the pressure cooker. Okay, with the pressure cooker. That's point 1. You haven't finished answering the question. We've got 3 marks here. Pressure cooker. For point 2, we are to explain. Okay, what's up? To explain. So in a pressure cooker, normally the high pressure allows water to boil at a higher temperature than in an aluminium pot. Okay, so in pressure cooker, you can mention, okay, in pressure cooker, higher pressure, okay, higher pressure allows water to boil. All right, allows water to boil at a higher temperature. Okay, and then how? Now how do you back this up? Okay, how to back up? Water molecules will collide or move faster. All right, or the kinetic energy lah. So the kinetic energy of water molecules are higher. 3 marks. Okay, just explaining this only. All right, now let's look at B. Let's get serious. Okay, table 9 shows the information about the experiments carried out by a student to investigate the factors that affect the rate of reaction between magnesium and hydrochloric acid. Okay, for experiment 1, all right, we've got reactants of excess magnesium ribbon reacting with 25 cubic centimeter of 0.5 mole over dm cube of hydrochloric acid, and the temperature is at 30 degrees Celsius. Okay, set 2, experiment 2, it has the same type, just that the excess magnesium, instead of ribbon, we're using powder. So let us highlight the key points first. Ribbon, powder, and still runs at the same temperature. Experiment 3, we are using powder, but okay, we are using the same type of chemicals. Everything is the same, just that at a higher temperature. All right. 1. Let's look at a question. State the definition for rate of reaction in experiment 1. If copper 2 sulfate solution is added to experiment 1, predict the rate of reaction for the experiment. So we are to predict the what do you call it? We are to predict lah, okay, what happened. So first thing first, all right, we can see this coming, that is, oops, increase in or change in volume of hydrogen gas per unit of time. Definitely this will happen. Okay, that's the first thing that will happen. Okay, that's the first thing that will happen. Point 1. Okay, so that is called the definition for rate of reaction in experiment 1 lah. Okay, increase or change in volume of hydrogen gas per unit of time. And then the next thing is, we know that when it happens like that, okay, the rate of reaction will definitely increase because we have added catalyst in. The catalyst for this reaction is copper 2 sulfate solution. So the rate of reaction will increase. All right, now that's for point 2. Okay, let's look at question 2. Write the chemical equation for the reaction that occurred between magnesium and hydrochloric acid in experiment 3. Calculate the volume of gas released for the experiment. 1 mole of the volume 24 over dm cube at room condition. Okay, let's prepare a separate sheet of paper for this. Okay. Okay, that's for question 9. Right, that will be number 9, 9B2. Okay, now what is the requirement? He wants you to write down the chemical equation for the reaction that occurred between magnesium and hydrochloric acid. So magnesium reacts with hydrochloric acid to form, okay, to produce magnesium chloride plus hydrogen gas, and this one need to be balanced. Okay, so it's balanced already now. Now, what is the question? Again, let's look. He wants in experiment 3, calculate the volume of gas released. So volume, how much? Okay, this one is in excess, so nothing to, don't disturb it. So for the acid, we've got 25 cubic centimeters, 0.5 molar. So the molarity is 0.5, volume is 25. So first step is calculate the number of mole of acid, which is mv over 1000. Okay, and you will get, all right, you will get yeah, okay, 0.5 times 25 divided 0.0125 mole. Okay, now there is one step that students always find it a redundant step, but actually it's a step that gives you mark. All right, so 2 moles of HCl will produce 1 mole of H2. So if in this case is 0.0125 mole of HCl, it will produce, divide by 2, which is 0.00625 mole of H2. So in other words, the volume of hydrogen is equals to 0.00625 multiplied by, given here is what the situation, we have to look back at the situation, 24 dm cube. Okay, 24 dm cube equals 0.15 dm cube. Okay, now, so how do we actually spread out the marks here for 5 marks? Huh? Okay, let's look at how do we spread out the marks. Point 1, able to write down the chemical equation. Second point, when you are able to balance out the chemical equation. Point 3, able to calculate the number of mole for HCl. Point 4, able to tell the ratio and proportionate that is involved. And point 5, the final answer. Okay, so that's how you get your 5 marks, 5 points, okay, for this type of question. All right, that's for question 2. Okay, now let's look at question 3, whereby you are to compare the rate of reaction between experiment 1 and experiment 2, and experiment 2 and experiment 3. Explain your answer based on the collision theory, which is a 10-mark question. So this type of question, I will always encourage students to go for table. Okay, so let's look at question 3. B3. First, you would like to focus on experiment 1 and 2. Okay, experiment 1 and 2. So experiment 1 and 2. Okay, 2. Sorry, this is 2. And then you must be wondering why the column is so small, right? Okay, later on I'll explain to you why. So most of your statements will be written in column 1, not column 2 and 3. Okay, column 2 and 3 is just writing in a more simplified manner. Okay, so in experiment 1 and 2, you will notice that, okay, the difference is in the size of particle. Okay, so size of magnesium. So size of magnesium. This one, for 1, it's bigger. For 2 is smaller. You see, that is why I put the column smaller. That means the title of your first column is very important. Okay, so what result in the size? What can you actually explain from the size itself? Okay, from the size of particle. Okay, how do you explain this? People wouldn't call it phenomena, but how do you explain that the rate of reaction, there is a difference there? Okay, when it comes to experiment 1 and 2, when it involves the size of a particle. Okay, now, so for size of particle, first thing, total surface area. Okay, total surface area of magnesium exposed to hydrochloric acid. Both sets are using hydrochloric acid. So please do mention hydrochloric acid. Okay, so total surface area for 1 is smaller because it's big piece. So when you drop it inside the beaker, it will not spread. So that is why the total surface area is smaller. But for 2, because it's in powder form, when you drop it into the beaker, it will spread open. So that is why the total surface area is bigger. Okay. Then, secondly, the collision. Okay, the collision in between. Okay, collision in between magnesium atom and H plus ion. Our focus for acid in this case is more onto the H plus, not the Cl. Okay, so collision between 1 and 2, 1 is lower, this one will be higher because it's widespread. Okay, so the collision. So the frequency, okay, of effective collision. Okay, this one will be lower, set 2 will be higher. So in a way, it contributes to the rate of reaction. Which one is higher, which one is lower? Rate of reaction. So for set 1, lower. For set 2, higher. That settles for experiment 1 and 2. Isn't easy, isn't it? When you tabulate something normally, it simplifies everything. You don't have to keep thinking of lengthy sentences. All right? That's for experiment 1 and 2. Okay, but firstly, in order for you to make sure that your table is actually very complete, you need to be very well versed on every factors, okay, on how to explain it as well. Now, let's look at the next one, which is set 1 and experiment 1 and experiment 2 and experiment 3. Okay, for experiment 2 and 3, the difference is the temperature, okay, the temperature. So in other words, you need to explain more on the temperature. Okay, now let's look at next factor. Experiment. Later on, then we break down the marks, okay? Experiment, we've got 3 and 2. Okay, for experiment 2 and 3, we know that the one that affects it is temperature. Okay, in experiment 2, the temperature is lower. The temperature in experiment 3 is higher. Okay, and then next, when it comes to explanation of temperature, okay, we have to mention the kinetic energy. Okay, the kinetic energy in between, if possible, state specifically magnesium and H plus. Okay, this is lower, this is higher. Okay, when the kinetic energy increases, okay, in another way, frequency of collisions between Mg and H plus, this one will be lower, increased. Okay, and then as a result, okay, frequency of effective collision this one you already mentioned here, you don't mention here also is okay. You need to mention at least one time when you explain on frequency of collision. So this one lower, this one higher. So as a result, the rate of reaction lower and higher. Okay, this is a 10-mark question. You should be happy if during your exam you are given this type of question, because why, you can get 10 marks easily if you really put the points on dot nicely. Okay, now let's break down the marks. Okay, 10 marks. So your first mark will be size of magnesium. Okay, second mark, total surface area. You are able to explain on the total surface area, but both must come in one set. Okay, if they don't come in one set, you cannot secure your mark. All right, collision in between magnesium atom and H plus ion, 0.3, and then effective collision, 0.4, and rate of reaction 0.5. Okay, so 5 marks for that. Now the next one, temperature lower and higher 0.6, kinetic energy 0.7. Okay, and then frequency of collision and frequency of effective collision. As a result, rate of reaction become higher. So it's that easy to secure your 10 marks. All right, so that's for question 9. All right, okay. Now let us continue to question 10. All right, continue question 10. 10A, diagram 10.1 shows the coral found in the sea around Tioman Island. This coral is formed from salt R. State the meaning of salt and state the solubility of salt R. So what is salt? Okay, what is salt? And also the solubility. So salts. Okay, let me show you how do you get your 2 marks here. Okay, so this is how you get your 2 marks. Let me. Okay. Ion compounds form when hydrogen ions in acids are replaced by metal ions or ammonium ions. That is the meaning of salt. And then the solubility of salt R, okay, it is insoluble. Otherwise, right, if it is soluble, it could have been gone already, but it still remain intact there. So meaning it is insoluble in the water. All right. Now, let's look at question B. Oops. 10.2, okay, shows the spillage of 200 cm cube of solution HX 2.0 mole over dm cube from a beaker on an iron table. Solution HX is corrosive and has a sour smell like vinegar. 1. Suggest a suitable HX solution. Select the suitable chemical found on the iron table to clean up the spillage HX solution and give your reason. Write a chemical equation to represent the reaction between your suggested chemical and HX solution. So this is 5 marks question. All right. Now let us see how do we deal with this type of question. Wait, Okay. Okay, since we still have place here, we continue with question 10 here. Okay, it's question 10 B1. Okay, so basically this is how you get your marks. First, you need to mention any form of acid which you know. Okay, because all acids are suitable. Be it weak or strong acid, in this case, it's all suitable. So any point of acid is accepted. Okay, second, for point 2, all right, suitable chemical found on iron table. to clean up the spillage HX solution and give your reason. Okay, so we have to find the type of chemical which is suitable. In this case, we use calcium carbonate. All right, calcium carbonate. Why? Because calcium carbonate can actually neutralize the solution HX without corroding the surface of the iron table. Okay, because why? I think you all should know that metal carbonate, when it reacts with acid, it will form carbon dioxide and water, which is also a form of neutralization. Okay, that means it does not corrode the surface. Okay, and then so next we have to write down the chemical equation. All right, next is write a chemical equation to represent the reaction between your suggested chemical and HX. So for example, if HX, you opt for HCl just now, okay, it will react with calcium carbonate to form calcium chloride plus CO2 plus H2O. You have to make sure that this is balanced, which isn't at the moment. Okay, so after you add 2 in front here, it has become a balanced chemical equation. That is why this is 0.4, the correct chemicals and the correct products, and 0.5 for a balanced chemical equation. So that is how we get 5 marks here. All right. The question looks very tedious because so much thing to read, right? But actually the answer is that simple only. All right. Now, let's look at the second one. Based on your suggestion in B1, B2, B1, okay, this is actually B1. Calculate the mass of chemicals selected to clean up all HX spills. So you have to calculate the mass of chemicals selected. That means your CaCO3 now, you have to calculate how much, because we've got 200 cubic cm of 2 mole. Okay, so we've got, so now is part 2. Okay, HCl, volume 200, molarity 2. We want to calculate, what again? We want to calculate the mass of chemicals selected. That means we want to calculate this one, the mass, how much. So what do? We calculate the number of mole of HCl first, which is 2 times 200 divided by 1000. So this is 0.4 mole. Okay, from the equation we know that 2 moles of HCl need to react with 1 mole of CaCO3. In other words, if it's 0.4 mole of HCl, it needs 0.2 mole of CaCO3. So the mass is equals to 0.2 mole multiply the RMM of CaCO3. Okay, calcium, the RAM is at 40. Okay, calcium is 40 plus carbon 12 plus oxygen 16, and there are 3 oxygen atoms, and which comes down to the final number, which is 40 plus 12 plus 48 times 0.2, 20 grams. Okay, now how do we put out the marks? 3 marks here. So first mark, you already, just now we have already balanced out our chemical equation. So for this one, it will be 0.1 at number of moles, 0.2 at ratio, and 0.3 is at your final answer. Okay, now that's for part 2. Okay, let's look at C now. Diagram 10.3 shows the reaction for the white solid V. Okay, white solid V reacts with nitric acid to form colorless solution W plus gas X plus water. Okay, now whereas for white solid V again, If it is heated, it will form yellow when hot, white when cold. Try to recall. If it is yellow hot, white cold means this is zinc oxide. Because we only learned a few types of salt, okay, which actually involves things like that. So zinc oxide. So definitely up here, if it is white solid, it's either zinc carbonate. Only zinc carbonate lah, because all carbonate salts are insoluble except ammonium, sodium, potassium, okay, and nitrate salt. Okay, otherwise all are insoluble. All carbonates are insoluble. Okay, so very obvious is zinc carbonate, meaning this colorless solution will be zinc nitrate plus CO2. Okay, now, so this one he will produce also gas X, come back here, so it's CO2 lah. Now, based on diagram 10.3, you must be wondering, how did I know? Okay, of course I know because I've been teaching for so many years, right? But the thing is, sometimes when it comes to this type of diagram, you need to catch certain special characteristics. Like for example, yellow when hot, white when cold. Definitely is zinc oxide. There's no other salt which we learn actually changes color when it becomes cold. Okay, except lead. Okay, lead is another one, lead 2 oxide, whereby it's brown when hot, yellow when cold. Only these two types. All right, so the number of salts that you learn are actually very limited, so don't be inconfident when it comes to answering salts question. Okay, now based on diagram 10.3, identify substance V, W, X and Y. So basically we have identified them all. Okay, we have identified them all. Okay, now 2, describe a chemical test to confirm the presence of cations and anions in solution W. Solution W, zinc nitrate. So what are the few chemical, okay, tests that we will always do? All right, now, wait, for zinc, okay, for zinc I will either use ammonia or even sodium hydroxide. Okay, because for zinc normally is very limited, we don't have many types of method. Okay, so for zinc the confirmatory test is normally, like for in this case I will use ammonia solution. All right, I will use ammonia solution. So this is for zinc. Okay, whereby you just mention slightly mention, you pour 1 to 2 cubic cm of solution W into test tubes A and B, and then add some ammonia solution little by little until in excess into test tube A and shake. A white precipitate forms and it dissolves in excess ammonia solution. So that is for zinc. All right, that's for zinc. Because zinc is very limited, the test is very limited to the extent that it's either ammonia or sodium hydroxide. You can even use sodium hydroxide. Okay, it doesn't limit down to just ammonia alone. Okay, now as for nitrate, when first thing that should occur in your mind when it is nitrate, it's always brown ring test. Okay, please remember nitrate always connected to brown ring test. And how do we do brown ring test? Add 1 to 2 cubic centimeter of diluted sulfuric acid followed by 1 to 2 cm cube of iron 2 sulfate solution into test tube B and shake. 5. Slowly add concentrated sulfuric acid into test tube and a brown ring is formed. Okay, slowly add is a very important step. Because why? If you don't add in slowly, you add in directly, your brown ring cannot be formed. Okay, so it has to be added and tilted. That means when you add slowly, it has to be against the wall of the test tube in order for the brown ring to be formed. Okay, cannot just simply just poop, 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 drop in. That's not right. Okay, so 1, 2, 3, 4, 5, 6. These are 6 marks answer. Okay, so that's it for section B. Now we're going into section C, which is question 11. And from the look of question 11, you've got periodic table of elements. You should be smiling if you have this type of question in the stimulus part. Okay, section B, section C used to be what is that? A section whereby students are allowed to choose in between 2 or for 1, but now they have make it a compulsory question whereby students must answer this question. Okay, for question 11. Now, let's look at table 11. Okay, it shows the proton numbers for 3 elements in the periodic table of elements, namely X, Y, and Z. Okay, we've got atom X, Y, and Z, proton number 12, 8, and 6. Okay, based on table 11, A, element X can form cation to achieve stable octet electron arrangement. Define cation and write the formula for the ion. Define cation. Cation is an ion which is positively charged. Okay, so cation is a positively charged ion. And then he wants what? Write the formula for the ion for X. So X is 2.8.2. So X2 plus. Always write, when you see this type of table, you always attack the table by writing down all the electron arrangement first. If you want to be safe, okay, if you want to be safe, this is what you should do. All right, that's for 2 marks. Let's look at B. Element Y can form 2 different types of compounds with element X and element Z. 1. Draw the electron arrangement for each type of compound formed. Okay, so we've got Y can form with X and also Z. Now, this type of question, if they ask you to draw the electron arrangement, you must draw the proper one, not using the Lewis structure. I don't advise you to use Lewis structure. Okay, don't use Lewis structure, because unless it's stated in the instruction to use Lewis structure, then you can do so. Otherwise, do not do that. Okay, I don't advise you to do that. All right, now let's try out with Y and X and Y first. Okay, so X and Y, you will get things like that, because they only ask you to draw the electron arrangement for each type of compound form, meaning the end product. You don't have to draw the entire formation, just the end product is enough. Okay, make sure it's in nucleus. Okay, and make sure both are stable with label of ion and anion, the cation and anion. Okay, whereas if it's for atom Y and Z, okay, atom, what is that? In this case, we will take Y and Z, yes. Okay, Y and Z, they have to be sharing. Okay, sharing of electrons. Okay, and it will be, the diagram will be something like that. Now, maybe some of you, sometimes you know what are all those elements, and then you start labeling it. Then if it is the correct one, never mind lah, you are safe. Otherwise, to be safe spot, if they say Y or Z, you just put as Y and Z. Okay, I will not advise you this one. Okay, this one can be accepted. Previously, we don't accept this because Y is in the middle of the shells. But I do encourage you, if possible, please draw it on the shell. Okay, if possible, draw it on the shell. Okay, because each of it are moving at its own orbit. It doesn't just suddenly come and combine in the middle like that. Okay, so this is 4 marks question. All right, let's look at 2. Okay, 0.05 mole of element Z reacts with excess element Y to form one of the compounds mentioned above. Write the chemical equation for the formation of the compound and calculate the mass of the compound formed. So you are given the molar mass of compound is 44 gram over mole. All right. Okay, how do we go about this type of question? Now, wait, because this one, oh, I have it all typed. Okay. Now let me create a new document for this. 11B2. 11B2. Okay. So this is what you should be the one. Oops, sorry. So your chemical equation has to be a balanced one. Okay, Z plus Y2, you get ZY2. Now, if you want to put other thing, but you have to make sure it must be the one with the same type of electron arrangement. So besides here, X will be, besides X, it can be 12. This one should be 12 will be magnesium. Besides X, it can be magnesium. Besides Y, it can be carbon. No, sorry, not carbon, oxygen. Besides Z, it can be carbon. Otherwise, if you put other substance in, other elements, it cannot be accepted. Okay, I cannot accept that. So the safest is always like that. Just put this. All right. Now, and then you have to make sure you have a mole ratio. We know that 1 mole of Z produces 1 mole of ZY2. So if it is 0.05 mole, so this is also 0.05 mole. So the mass of compound ZY2 form will be 0.05 multiplied by 44 grams, which is 2.2 grams. It's all stated in the question here, given already. Your molar mass of compound is already given, which is 44 grams over mole. Okay? Now, let's look at question C now. Okay, this question C is diagram 11. Okay, diagram 11.1 shows the formation of two types of bonds, bond E and bond F. Okay, bond E, bond F. All right, and then I think they want you to state what is bond E, what is bond F. So for bond E, what is bond E? Bond E is hydrogen bond. Okay, bond E is hydrogen bond. What about bond F? Bond F is the dative bond. Okay, because of this, the extra two which get attracts to another one, okay, then that is dative bond. Okay, if it forms in between this hyphon, the key is hyphon. That means hydrogen attached over to oxygen, fluorine, or nitrogen. It's normally hydrogen bond. Okay. Now, D. Tiara found 2 unlabeled bottles of white powder left on a table in her school laboratory. Tiara brought the 2 bottles to show her chemistry teacher because she wanted to know the type of compound for the 2 white solids. Her teacher asked Tiara to label the bottles with powder A and powder B. Her teacher also gave some apparatus to Tiara and asked her to conduct an experiment to compare the physical properties of the 2 substances. Diagram 11.2 shows the list of apparatus given by the teacher. Okay, these are all the apparatus. Using the list of apparatus given, describe an experiment to study the difference in the physical properties of powder A and powder B. Include observation and conclusion of the experiment. Okay, so what would she do first? She want to check, okay, if all these are actually powder A and powder B, what type of compounds they are actually. Okay, so how does she check? Normally we will use that technique whereby we check whether our bulb will actually increase on will actually light up or not. Okay, normally that's how we check. Okay, now let's look at how do we put this answer. So first we fill 3 spatulas of powder A into a crucible. Okay, insert 2 carbon electrodes into powder A and connect it to a battery and bulb with connecting wire. These one are all very compulsory answers you must have. Okay, then we are to record the observation of whether the bulb lights up or not. Heat powder A strongly until all solids have melted. Then record the observation. After recording, then repeat steps 1 to 5 using powder B to replace powder A. So the observation are as follows. That means you have to check whether in the state of solid, does it light up the bulb, or in the form of molten, does it light up the bulb. Okay, in this third state would do. All right. Now, so in conclusion, we can conclude that powder A is an ionic compound, while powder B is a covalent compound because of the fact of the condition of the bulb. All right, because in powder B, the bulb does not light up at all in any form of condition. So that's how you get the full 8 points here. All right, every single steps have to be stated. This one, if you do not have connecting wire, you will not get your mark also. Okay, so that's it for this paper from Pahang. So I hope what is discussed today is very clear to you. Okay, and I hope that you are able to understand, okay, whatever has been discussed in the entire paper right from paper 1. Okay, thank you.